name is April Joy Olayer Elducal, and so my task is to give 20 examples about descriptive and inferential statistics. So for the descriptive statistics, we have the measure of central tendency, which is the mean, the median, and the mode, and the measure for variability, which is the minimum, maximum range, standard deviation, and the variance. Let's say that there are 10 statistics classes at your campus and you've collected the ages of the students in one class. So the ages of the students are 19, 21, 19, 18, 34, 30, 25, 23, 24, 24, 19, 21, and so there 27. Are 13 who were hypothetically selected. So the descriptive question here is, what's the most common age of the students? We have here 19, and that's way too obvious, so 19 is the most common age of the students. Imagine that you are interested in measuring the level of anxiety of college students during finals week in one of your courses. You have 11 study participants rate their level of anxiety on a scale of 1 to 10, with 1 being no anxiety and 10 being extremely anxious. You collect the ratings and review them, and the ratings are 8, 4, 9, 3, 5, 8, 6, 6, 7, 8, and 10. Your teacher asks you for the summary of your findings. How do you summarize this data? One way we could do this is by using descriptive statistics. Knowing what we know, let's calculate the mean, median, and mode using the examples from before. Again, the anxiety ratings of your classmates are 8, 4, 9, 3, 5, 8, 6, 6, 7, 8, and 10. So for the mean, we will add all those numbers and divide it into 11. So we will have 74 divided by 11, and the mean is 6.73. For the median, in the data set of 11, so the median is the number in the 6th place, so the median is 7. For the mode is the number 8 appears more than any other number, so the mode is 8. Here are the 20 observations for sample data. So the first thing we do is summarize this data and arrange these numbers. Here we will determine the mean and the median of this data. So the mean is 91.45 and the median is 97.5. So we have here the popularity of different leisure activities by gender. So for the variable of gender, you list all the possible answers. We have the gender for the male, female, and some got no answers. So for this table, you can see that more women took part in the study. So for our next example, we have here the number of cans of Coca-Colas consumed by teenagers each day is the subject of an empirical study. So we have here the cans per day, the 0, 1, 2, 3, 4, and 5. The number of teens who consume cans of Coca-Cola each day, we have 25 for 0, 1, 30, 26, 20, 14, and 10. So for the first one, we have to calculate for the mean, median, and mode for this sample. So for the mean, we have here is 30 plus 52 plus 60 plus 56 plus 50. So where did we get there this number? So we get there from this sample. So we have 25 multiplied to 0, so that's 0. And we have 30 here. 30 times 1 is equal to 30. We have 30. 26 times 2, we have 52. 60, because it's 20 times 3. 14 times 4, we have 56. And we have 10 times 5 is equal to 50. So we end up having this. We add this number, so we have 248 divided by 125, so we have 1.984. for our mean.
For the median, we will have 125 divided into 2. So we will have 63 or something, or the 63rd position. So where we get the 63rd position in this table? So we will get the 63rd here in the number 2. So we have 25 plus 30, we have 55. 55 plus 26 is equal to, we will have 55 plus 26 is equal to 81. So the 63rd position is we will find in between these two, and the nearest is 2. So we will have 2 as our median. For the mode, we will have 1, the highest frequency of them all. So these are the values and these are the frequencies. The highest frequency is 30, so we will have 1. So that's it. The mean, median, and mode for the numbers of beans consumed. No, for the number of cans of Coca-Cola consumed by teenagers.
We've seen how descriptive statistics can be used to describe distribution. In particular, we have the central tendency and in dispersion. In addition to descriptive statistics, we need to understand inferential statistics. Inferential statistics. Inferential statistics sample data from small number of people and try to predict possible outcomes. Uses random and unbiased sampling methods. Here is the first example. You might stand in a mall and ask a sample of 100 people if they like shopping at Gaisano. You could make a bar chart of yes or no answers, and that would be descriptive statistics. And use your research to reason out that 75 to 85% of populations like shopping at Gaisano. In a mythical national survey, 225 students are randomly selected from those taking calculus and asked if calculus is their favorite subject. 100 students reply that calculus is their favorite subject. Give a 95% confidence interval for the proportion of all students taking calculus who consider it their favorite subject. Here is our solution. Suppose a random sample of 225 undergraduate men at UMD that the average best bench press is 150 pounds, with sample standard deviation of 20 pounds. Compute a 95% confidence interval for the average bench press for UMD undergraduate men. Here we have our solution. Of 350 randomly selected people in the town of Lucerna, Italy, 280 people had the last name of Nicolosi. An example in inferential statistics is the following statement. 80% of all people living in Italy have the last name of Nicolosi. We have no information about all people living in Italy, just about 350 in Lucerna. We have taken that information and generalized it to talk about all the people living in Italy. The easiest way to tell that this statement is not descriptive is by trying to verify it based upon the information provided. A substitute teacher wants to know how students in the class did on their last test. She only asks 10 students sitting in the front row to report how they did, and she concludes from them that the class did extremely well. The sample is 10 students sitting in the front row. The population is all students in the class, and the problem is that the sample is biased. Data was collected in the number of hours. It took 30 students to finish reading the book. It was noted that the average is 7 hours. This implies that the average hour is 7 for n students. To determine the proportion of Democrats in the Republic, a survey was conducted by a researcher in Pasay City, and he found out that 65% are Democrats. There is generalization. Why? Because the researcher took Pasay City as a sample and then established that 65% are Democrats. The coach is interested in how many cartwheels the average college freshman at his university do. 8 volunteers from the freshman class step forward. After observing their performance, the coach concludes that college freshmen can do an average of 16 cartwheels in a row without stopping. The population is a class of all freshmen at the coach's university. The sample is composed of the 8 volunteers. The sample is poorly chosen because volunteers are more likely to be able to do cartwheels than the average freshman. People who can do cartwheels probably did not volunteer. In the example, we are not also told the gender of the volunteers. Inferential statistics provide a way of going from a sample to a population.
Good afternoon, sir. My assigned topics, I will give 20 examples of qualitative data and quantitative data. Before we proceed to the examples, let us define first what is qualitative data and quantitative data. So, qualitative data is also called categorical data since these data can be grouped according to categories. They have labels or names assigned to their respective categories, and also it can just be observed and not evaluated. Here are examples of qualitative data. So first is sense, so smell or odor. Next is appearance. Next is beauty, beautiful or ugly. Next is colors, black, white or green or etc. Flavors, chicken or beef. Happiness rating. Next is gender, female or male. Next is grades, pass or fail. Next is eye color, brown or blue. Next is texture, soft or sticky. Next is categories of plants. Next is descriptive temperature of coffee. It can be hot or cold. Next is year level, from first year to fourth year. Next is region, IFI, RC, and born again, and etc. Next is employment. Next is course, BSW, BSN or BSIT, and etc. Next is judicial cases handled, and next is employment, and next is type of player, and the last is shape of candidates and a variety pack. So qualitative data is important in determining the particular frequency of traits or characteristics. It allows the statistician to form parameters through which larger data sets can be observed. Qualitative data provides the means by which observers can quantify the world around them. So next is quantitative data. Quantitative data is a bit like a countable nouns. They both refer to things that can be counted even if it seems like it take a lifetime to measure. Here are examples of quantitative data. So, number 1, a jug of milk holds 1 gallon. Next is the painting is 14 inches wide and 12 inches long. Next is the new baby weighs 6 pounds and 5 ounces. Next is a bag of broccoli crowns weighs 4 pounds. Next is a coffee mug holds 10 ounces. Next is John is 6 feet tall. Next is a coffee mug holds 10 ounces. And next is the cake was 50% chocolate and 50% vanilla. Next, a tablet weighs 1.5 pounds. Number 10, 98% of the graduating high school class is going to college. Number 11, a first grade classroom, there are 12 boys and 9 girls. Next is an entire school, there are 523 students. And next is the airplane can hold 93 passengers. And next is the water in the deep end of the pool is 9 feet deep. Number 15, the apartment is 550 square feet in size. And number 16, the number of letters in the alphabet is 26 and 5 of them are vowels. And number 17, there are 10 city blocks in 1 mile. Number 18, the house has 20 windows. Number 19, the women's weighs 178 pounds. And number 20, the customer bought 2 televisions. So the purpose of quantitative data is to generate knowledge and create understanding about the social world. Quantitative data is used by social scientists, including communication researchers, to observe phenomena or occurrences affecting individuals. So that's all. Thank you.
3, 2, 1.
Hi everyone, this is Melanie S. Kailan from BSSW 3B. So for today's video, I'm going to present to you the levels of measurements and its examples. So by the way, there are 4 levels of measurements. These are nominal scale, ordinal scale, ratio scale, and interval scale. So first scale is the nominal scale. It's a scale of measurement used to assign events or objects into discrete categories. This form of scale does not require the use of numeric values or categories ranked by class, but simply unique identifiers to label each distinct category. Here are some of the examples of nominal measurement that will help in understand this measurement scale better. So first example, how would you describe your behavioral pattern? So there are 3 categories which you will choose. So E for extroverted, I for introverted, and A for ambivert. Second example, what is your gender? So M for male and F for female. Third example, could you please select an option from below to describe your hair color? So 1 for black, 2 for brown, 3 for burgundy, 4 for auburn, and 5 for other. So fourth example, type of living accommodation. So house, apartment, trailer, and other. So fifth example, what is your religious preference? Buddhist, Mormon, Muslim, Jewish, Christian, and other. So for the second level of measurement, which is the ordinal scale. Ordinal scale is the second level of measurement that reports the ranking and ordering of the data without actually establishing the degree of variation between them. Ordinal level of measurement is the second of the 4 measurement scale. Ordinal indicates order. Ordinal data is quantitative data, which have naturally occurring orders, and difference between is also unknown. It can be named, grouped, and also ranked.
For example, first example, how satisfied are you with our products? So 1 for totally satisfied, 2 for satisfied, 3 for neutral, 4 dissatisfied, and 5 for totally dissatisfied. So for the second example, how happy are you with the customer service? 1 very unhappy, 2 unhappy, 3 neutral, 4 unhappy, 5 very unhappy. So for third example, ranking of the highest school students. First, third, fourth, and 10th. A student scoring 99 over 100 would be the first rank. Another student scoring 92 over 100 would be the third, and so on and so forth. So for the fourth example, rating surveys in restaurants. When a waiter gets a paper, an online survey with a question, how satisfied are you with the people dining experience? Having 0 to 10 option, 0 being extremely dissatisfied and 10 being extremely dissatisfied. And so for the fifth example, evaluating the degree of agreement. State your level of agreement with the company policies. Totally agree, agree, neutral, disagree, and totally disagree. So we'll proceed to the third levels of measurement, which is the ratio scale. A ratio scale is a scale of measurement created by units of equal size like an interval scale, with the added condition that 0 is not an arbitrary. So the following are the most commonly used examples for ratio scale. First example, what is your height in feet and inches? Less than 5 feet, 5 feet and 1 inch, or 5 feet and 5 inches, 5 feet and 6 inches, or 6 feet and more than 6 feet. So, second example, what is your weight in kilograms? Less than 50 kilograms, 51 to 70 kilograms, 71 to 90 kilograms, 90 to 110 kilograms, and more than 110 kilograms. Third example, how much time do you spend daily watching television? Less than 2 hours, 3 to 4 hours, 4 to 5 hours, 5 to 6 hours, and more than 6 hours. So for the fourth example, let us take the example of speed to understand the scale better. Physics defines speed as speed in the distance traveled per unit time. Here, the unit for time can be kept constant and a unit for distance traveled can vary. For example, can be in a kilometers or miles, which means 20 kilometers per hour is equivalent to 12.43 miles per hour. So for the fifth and last example is the age can be measured on the ratio scale. So our last level of measurement is the interval scale. So the interval scale is a quantitative measurement scale where there is order. The difference between the two variables is meaningful and equal, and the presence of 0 is arbitrary. It measures the variables that exist along a common scale at equal intervals. The measures used to calculate the distance between the variables are highly reliable. First example of interval scale is time. Time is an example of an interval scale because there is no meaningful 0. So second example would be Fahrenheit and Celsius. Third example is credit score. Someone with a credit score of 720 has a higher score than someone with 650. So for the fourth example is one of the most commonly used interval scale questions is a range on a 5-point Likert scale question, where each emotion is denoted with a number, and the variables range from extremely dissatisfied to extremely satisfied. So, customer satisfaction is key to organizational growth. 1. Completely agree. 2. Somewhat agree. 3. Neutral. 4. Somewhat disagree. 5. Completely disagree. So, for the fifth and last example is the Net Promoter Score or NPS. In a Net Promoter Score question, the respondents reply on a scale of 1 to 10 rating how likely they are to refer a company, product, and service to peer. So 1 to 6 is detractors, 7 to 8 is the passives, and 9 to 10 is the promoters. To sum up with these levels of measurements, so a nominal scale is a scale that categorizes items. An ordinal scale is a scale that categorizes and rank orders items. And an interval scale is a scale that categorizes and rank orders items and has equal intervals. So, for the last, ratio scale is a scale that categorizes and rank orders items, has equal intervals, and a zero that means the absence or none of the thing being measured. That's all, and thank you.
Hi everyone, this is Felipa B. Tan, BSSW 3A. So the first method is direct method or an interview method. So the researcher has direct contact with the interviewee. The researcher gathers information by asking questions to the interviewee. Example 1. Multi-liver company would interview mothers regarding their favorite brand of toothpaste, soap, or shampoo. So the advantage is that the researcher can get more accurate answers since clarifications can be made if the respondent does not understand the question. So the disadvantage, this method is costly and time consuming. So the number 2 example is licensure or certification. So nursing program students pass rates on the NCLEX or nursing examination. Then the third example is the national exams of or standardized tests. So freshmen and seniors course in the College Learning Assessment or CLA or College Assessment of Academic Proficiency or CAAP. B. Senior level biology students course on the GRE subject test on biology. So number 4 examples is the local exams or external to courses. So entering students scores on the MANOA writing placement exam. Note, these local exams are not course exams. So the fifth example is grades calibrated to clear student learning outcomes. So professors give grades based on explicit criteria that are directly related to particular learning outcomes. And the sixth example is portfolios. So a collection of student work such as written assignments, personal reflection, and self-assignments. So developmental portfolios typically include work completed early, middle, and late in the student's academic career so growth can be noted. Showcase portfolios include students' best work and aim to show that students' highest achievement level. So, another example, the seventh example. So, employers or internship supervisors direct evaluations of students' performances. So, evaluation or rating of student performance in a work, in internship, or service learning. Five example is interviews. So, face-to-face, one-to-one discussions or question or answer session. Example, a trained peer interviews seniors in a program to find out what courses and assignments they valued the most and why. So the sixth example is grades given by professors that are not based on explicit criteria directly related to a learning outcome. So, grade point average are grades of students in a program. Example, 52% of the students in foundations written communication courses receive an A or A plus or a negative grade. So the seventh example is job placement data. So the percent of students who found employment in a field related to the major or program within 1 year. So let's proceed to registration method. This method is governed by laws. So example, the number of registered professionals can be found at the Professional Regulation Commission or PRC. The number of births and death rates are registered in the National Statistics Office or NSO. So the advantage here is this method is the most reliable since it is enforced by laws. And the disadvantage is data are limited to what are listed in the document. So, let's proceed to observation method. This is when you collect data by observing and noting down your results. So, you must be aware and avoid any biases in your results. Ensure you think carefully about the locations and days or times at which you carry out your observations. So, the example rather. At first, the client sat stiffly on the chair next to the receptionist's desk. She picked up a magazine and let the pages flutter through her fingers very quickly without really looking at any of the pages. She then set the magazine down, looked at her watch, tugged at her skirt, and picked up the magazine again. This time, she didn't look at the magazine. She set it back down, took out a cigarette, and began smoking. She would watch the receptionist out of the corner of her eye, and then look back down at the magazine, and back at the two or more people waiting in the room. Her eyes moved from the magazine to the people, to the cigarette, to the people, and to the magazine in rapid succession. She avoided eye contact with anyone in the room. When her name was finally called by the receptionist, she jumped up like she was startled. So, the last method is experimental method. This method is utilized to find out cause and effect relationships. So, example, medical technologists would like to know the effect of a new brand of vitamins on the growth of toddlers. The new brand will be taken by a set of toddlers, while another set will be given the already existing brand. The growth of toddlers will then be compared to determine which vitamins rather is better. So the advantage here is this method goes beyond plain description of data. And the disadvantage is care should be taken on making conclusions to the result of the experiment. Thank you. That's all, and thank you.
So go Jay, welcome back. And now, my vlog content is all about my sampling techniques and a random sampling is a sampling where every member of the population has an equal chance of being selected. Example, a researcher could number each of member of the population to get sample of a population of 90 members. Then it can be placed number cards 1 to 90 in a mixer and select as many cards needed to complete a sample. Or they can use a calculator or computer to generate random numbers. So stratified sample is a sample where the researchers divide the population into subgroups to have members from each segment of a population, and then random sampling were derived from each subgroups. Example, you wanted to know how much money saved in a yearly basis. So you can here in all of the population needed, so you can select them to create subgroups like this. And then from these different subgroups, you can randomly select each of the people here to create your sampling method. Next is this cluster sampling. A cluster sampling is obtained by dividing into sections or cluster, then randomly selecting in one or more clusters and using all of its members for members of a sample. This is usually used in a large scope area. Example, you want to survey small business owners in a very populated area. So you can create cluster sample using zip codes or by barangays or by sitios to obtain your needed data. Examples, this is the zip code in one selected area, and this one is another area. So this is your clusters in samples to create your cluster sampling. And lastly is the systematic sampling. Researchers will assign a counting number to every member of a population, then select the random number, then select member from a sample from a regular members for a random number selected. Example, you want to know how much time spend people living in their houses just watching television on a weekly basis. You want to get sample of 50 members. There were 1,000 houses in the complex. You could number the units 1 to 1,000 and generate the random starting number, says 234. Since you want a sample of 50, so you could divide 1,000 to the number of a population by 50. This is the guiding solutions. Number 1, number units 1 to 1,000. Number 2, generate random starting numbers. Example, that 234. Number 3, find interval number. So, number of the units divided by sample use wanted. So, 1,000 divided by 50 is equal to 20. And then number 4, select sample members. Example is the number 34. So, number 34, then let us add the 20 as our interval is equal to 254. And then 254 plus 20 is equal to 274.
So, hi guys, good morning. Today's day, I will explain to you the methods in presenting data. So first, what is presentation of data? Presentation of data. This refers to the organization of data into tables, graphs, and charts. So, data may be presented in three methods: textual presentation, tabular presentation, and graphical presentation. Textual presentation of data means presenting data in the forms of words, sentences, and paragraphs, and a combination of text and figures. Second presentation is the tabular presentation. Data collected is a form of rows and columns. It is an orderly arrangement which is compact and self-explanatory. And the third one is the graphical presentation of data. Data are presented in visual forms. Graphs may appear in many forms, just like line, bar, picture graphs, and other way in presenting data. This graphical presentation of data, sometimes we can see it in newspapers, magazines, periodicals, and business reports. So that would be all. Thank you for watching. God bless.
Hi mga kapamilya, kapuso, kapatid! Welcome to Sophia Base Video! This video, where we're going to tackle about frequency distributions table. So there are 4 categories of frequency distribution table. First is the parts of frequency distribution table. Secondly, the nomenclature of frequency distribution table, or the nomenclature of tabulations. Third is the types of frequency distributions table. And lastly is the variations of frequency distribution table. First is we're going to tackle the parts of frequency distribution table. Our lesson for today is frequency distribution table. So first we're going to tackle the parts of our frequency distribution table. So letter A, parts of FAT. So the parts of FAT consist of A, feeding, B, box head, C, stop, D, field, and lastly the source node. So these 5 parts of FDT, you can see it in the table, and you can see it here in the table. I'm going to draw the table so that we can identify where these 5 parts of FDT belong. So in the above of this table, this is what we call the heading. So this is the heading, which is the table number, or what we call the heading. And the box head belongs here. So the box head consists of what we call the spanner head. So this is the spanner head, or the box head. And the stub belongs here. This is the stub head. And the field is located here. So this is the field. And the source node belongs here. So this is the source node. So source node is depends upon of what site or what is or ahan mo dapat gikuha ang imong table. So dili na belong ang source node. So that's all the parts of frequency distribution table. So next we're going to proceed the nomenclature of tabulation. So next category is the nomenclature of tabulations. Nomenclature of tabulations consists of 7 parts. So first is the frequency distribution table. So the frequency distribution table is the summary of the distributions of observations. Secondly is the class intervals. So the class intervals is the 2 parts of limits, the lower limits and the upper limits. Secondly and thirdly is the class boundaries. So class boundary is composed of 2 parts, the lower class boundary and the upper class boundary. So the lower class boundary is the average of the lower class limit of the interval and the upper class limit. While the upper class boundary is the average of the upper class limit of the interval and the lower limit of the succeeding interval. So fourthly is the class width. So class width is the difference of the highest and lowest value of the set. Lastly is the class marks. So class mark is the midpoint of the class interval. So how can we get class boundaries, class width, and class mark? So at later on of our discussions, we will know on how to get these class boundaries, class width, class marks, and as well as class intervals. So the third category of the frequency distributions is the type of frequency. So letter C is types of frequency distributions. So there are three types of frequency distributions. First is the categorical FDT. Second is the ungroup FDT. Thirdly is the group FDT. So the categorical FDT is used for data that can be placed in specific categories. So for example, ang wrong table is kung ani siya. So palitan, categorical man siya no, so year level. Yun yung number. So since categorical man siya, so first, gonna put your first year, second year, third year, and fourth year. So in the categorical FDT, your table looks like this because it's categorical. So for example, your table is the year level, so first year, second year, third, fourth year. So second is the ungroup FDT. So use for numerical data wherein the range difference between maximum and minimum value is small. For example, the ungroup data is 1, 2, 5, 8, 11, 14, 17, 20. So this is what we call ungroup FDT. So it is ungroup because kanang nagkuan man sa diba wala man siya nag-group diba. So wala siya ang ungroup data. So thirdly is the group data. So the group FDT. So the group FDT, it is a group of members that has already a width and a range. So for example, of group data, so sa imong table, ano na siya? May group naman siya. So more na siya og categorical, more na siya tinanani sa categorical ang group data. For example, ang year level, so naa na siya class interval, unlike sa ungroup data, pangitaon pa na to ang iyang class interval. Sa group FDT, naa na siya class interval. For example, 18 to 24, 24 to 27. So ano siya ang example sa group FDT? Naka-group na siya, naa na siya class interval sa table. So that is the types of frequency distribution table. So next is the so last category of FDT is variation of FDT. So variation of FDT composed of three: the relative, cumulative, and percentage. So in our next discussions, we will going to know on how to solve relative FDT, cumulative FDT, and percentage FDT. All of categorical FDT. So the following table shows the list of characters captured in 2 hours of playing. So these are plastic, insect, wet, metal, plastic. So we are going to categorize it into a table. So one. This is the class and frequency. So first is plastic. Second, insect. Thirdly, wet. Fourthly, metal. And lastly, liquid. So to get the frequency, we're going to tally how much is the plastic, the insect, the wet, the metal, and liquid. So we're going to count it. So plastic is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 plastic. Insect 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 insect. Wet. 1, 2, 3, 4, 5, 6. Metal 1. There are 2. There's only 2 metal. Liquid 1, 2, 3, 4. 4 liquid. This is what look like the categorical FDT. So this is the table of categorical frequency distributions table. So we already tackled about the categorical frequency distribution table. Now let's proceed to the next type of FDT, which is the ungroup frequency distribution table. So I have here an example of ungroup frequency distribution table. So the example is Mr. Andres was asked to present the performance of his business class in the following exam. The following are the test scores. So these following numbers is the test scores of his students. So this is 34, 50, 37, 34, 49, 42, 18, 38, 29, 48, 20, 35, 38, 25, 46, and so on. So first we're going to identify its range, which is range is the highest volume number minus the lowest volume number of the set data. So since the highest number of the set of data is 50 and the lowest number is 50 and the lowest number is 9. So range is 50 minus 9 equals 41, and we're going to find the width. So width is 41 divided by 6, well 6.8 or 7. So you will be asked, asa gikan ang 6? So ang 6 is always depend your class intervals. Kung pinakabuok mo class intervals sa buhaton, so mauna siyang i-divide nimo sa difference sa range. So I'm going to show to you the table
of the ungroup data. So as you can see earlier that our width is 7 and we already saw the set of data of numbers in the ungroup. So first we're going to find the class intervals. So the lowest number there is 9. So we're going to put the 9 here. So this is your first lower limit. So 9 plus 7 equals 16. 16 plus 7 equals 23. Okay, yung plus 27 man. So 23 plus 7 equals 30. 30 plus 7 equals 37. 37 plus 7 equals 44. So you will be asked, paano sa mali mo pa o nang upper limit? So you will just minus, the lower limit here, you will just minus it by 1. So isubtract lang mo siya 1, mo siya ang upper limit here. So 16 minus 1 equals 15. 23 minus 1 equals 22. 30 minus 1 equals 29. And 37 minus 1 is 36. And here is 43. And here is 50. And you will just add 50 with your class width. So 50, because since your class is 7, so 50 plus 7 equals 57. So we're going to find our frequency. So paano naman po na po ang frequency? So paano na po ang frequency? We're going to tally the number of our set data here so that we could get our frequency. So we already done tallying our set number of data. So our frequency here, so 9 to 50 is 1, 16 to 22 is 3, 23 to 29 is 8, 30 to 36 is 4, 37 to 43 is 9, and 44 to 50 is 13. So the total of our frequency is 38. So next we're going to find the class width. So in finding the class width, we are just going to subtract our highest lower limit to lowest lower limit. So 16 minus 9 equals 7. So our class width is 7. So next is the class boundaries. So in the class boundaries, you will just going to subtract the higher lowest number, subtract to the upper limit. So 23 minus 22 is 1. Divided by 2 equals 0.5. So after that 0.5, so 0.5 we're just going to subtract it in 9. So 9 minus 0.5 equals 8.5. 16 minus 0.5 equals 15.5. 23 minus 0.5 equals 22.5. 30 minus 0.5 equals 29.5. 37 minus 0.5 equals 36.5. And 44 minus 0.5 equals 43.5. And here in the upper class boundaries, you will just going to copy your lower class boundaries. So 15.5, you're going to put it here. 22.5, the 29.5, the 36.5, the 43.5, and dire, you'll just add 43.5 by 0.5. So 43.5 plus 0.5 equals how much? 44. So that's how you get the class boundaries. So next is the class marks. So in the class marks, you are just going to add your class interval and divide it by 2. So 9 plus 15 divided by 2. So 9 plus 15 equals 24 divided by 2 equals 24 divided by 2 equals 12. And the class mark here is 19. The 23 to 29 is, so 23 plus 29 equals 52. Divide 2 is 26. So 30 and 36 equals 66. Divide 2 is 33. 37, 43, 70. Divide 2 is 40. 37 plus 43 equals 80. Divide 2 equals 40. And 44 to 50 is, ayan, plus 1 is 47. So next is, we're going to solve the percentage frequency. So in adding the percentage frequency, so in getting the percentage frequency, we're just going to divide the frequency and the total of the frequency. So 1 divided by 38 and times it with 100. So in the number 1, so in our frequency is 1, we divide it by 38, and we times 100 and that, and the percentage of frequency is 2.63. And here, 3 divided by 38 times 100 was 7.89. Third, 8 divided by 38 times 100 was 21.05. 4 divided by 38 times 100 equals 10.52. 9 divided by 38 times 100 was 23.43. And lastly, 13 divided by 38 times 100 equals 34.23. And next is the relative frequency. So relative frequency, you will divide our frequency divide the total number of frequencies. So 1 divided by 38 equals 0.026. 3 divided by 38 equals 0.70. 0.076. 8 divided by 38 equals 0.21. 4 divided by 38 equals 0.10. 9 divided by 38 equals 0.23. And 13 divided by 38 equals 0.34. In the cumulative frequency, you're just going to add your frequency. So first here is the frequency is 1. And 1 plus 3 equals 4. 4 plus 8 equals 12. 12 plus 4 equals 16. 16 plus 9 equals 25. And 25 plus 13 equals 38. So that's it. So that's how you're going to solve the class intervals, the frequency, class width, class boundaries, class marks, percentage frequency, relative frequency, cumulative frequency. So it's very easy. You can really solve it if you're going to just analyze it. So that's it. So and now let's proceed to the group frequency distribution table, the last type of FDT. So we have here an example of group frequency distribution table. So we have here the temperature of the month of April. Find the class width, boundaries, marks, and duration of frequency distribution table. So So, ano siya ang mga temperature sa nga nakuha sa month of April. So, we have here the table of our group frequency distributions table. So, we have the class intervals, frequency, class level, smart, percentage, relative, community. So, ang atuan pangitaon din sa table is ganito lang. So, we have here our class intervals, 31, 35 to 71 to 75. Our frequencies 2, 3, 6, 5, 1, 54, 4, 2, the total of 30. So, in finding the class width, we are just going to subtract 36 minus 31, and the class width is 5. And in finding the class boundaries, you're just going to subtract 36 minus 35 and divide it by 2, so the answer is 0.5. So 0.5, subtract it in the lower limit, which is 31. So 31 minus 0.5 was 30.5. 36 minus 0.5 was 35.5. And 41 minus 0.5 was 40.5. 46 minus 0.5 was 45.5. 51 minus 0.5 was 50.5. 56 minus 0.5 was 55.5. And 61 minus 0.5 was 60.5. 66 minus 0.5 was 65.5. And 71 minus 0.5 was 70.5. So in the upper class, so this is the lower class boundaries. So in the upper class boundaries, you are just going to copy your lower class boundaries. Ano siya? So here is 35.5, 40.5, 45.5, 50.5, 55.5, 60.5, 65.5, and 70.5. So you're just going to add 70.5 by 0.5, so here is 71. So next is, so in the class mark, so you're just going to add this two number and divide it by 2. So 31 plus 35 divided by 2 equals 33. 36 plus 40 divide 2 equals 38. 41 plus 45 divide 2 equals 43. 46 plus 50 divide 2 equals 48. 51 plus 55 divide 2 equals 53. 56 plus 60 divide 2 equals 58. 61 plus 65 divide 2 equals 63. 66 plus 70 divide 2 equals 68. 71 plus 75 divide 2 equals 73. So next is the percentage. So in getting the percentage, you're just going to divide the frequency over the total amount of frequency and times it with 100. So in percentage is 2 divided by 30 times 100 equals 6.66. 3 divided 30 times 100 equals 10. Percentage of this. 6 divided 30 times 100 equals 16.66%. 5 divided 30 times 100 equals 3.33%. 1 divided 30 times 100 equals 10. And 3 divided 30 times 100 equals 10%. 4 divided 30 times 100 equals 13.33%. Another here, 13.33%. And 2 divided 30 times 100 equals 6.66%. Next, the relative frequencies, we're just going to divide frequency over the total of frequency. So 2 divided 30 equals 0.06. 3 divided 30 equals 0.1. 6 divided 30 equals 0.2. 5 divided 30 equals 0.016. 1 divided 30 equals 0.1. 1 divided by 30 equals 0.033. 1 divided 30 equals 0.033. 3 divided 30 equals 0.1. 4 divided 30 equals 0.13. And also here. 2 divided 30 equals 0.0. So in the cumulative frequency, you're just going to add your frequency number. So we're just going to copy the 2 here. 2. 2 plus 3, 5. 2 plus 3, 5. 5 plus 6, 11. 11 plus 5, 16. 16 plus 1, 17. 17 plus 3, 20. 20 plus 4, 24. 24 plus 4, 28. So this is the frequency, and 28 plus 2 equals 30. So this is the cumulative frequency. So cumulative frequency should be the same with the total of your frequency number. So that's it. So that's how you're going to solve the types of frequency distribution table and as well as the variations of frequency distribution table. So I hope you learned something for my discussion today. And thank you, and God bless us also. That is the ending of my video. So bye! See you on my next discussion.
So my assigned topic is a frequency distribution table. So, a group frequency distribution is the data that bundled together in categories. So, our data formed by aggregating individuals observation variable into groups, so that frequently distribution serve as a convenience mean. So a group frequency distribution is a very convenient means of summarizing data. So as you can see in my example here, okay, so we have the number of unhealthy people in selected rural areas. So we have here the number of data given. So the very first thing that we need to do is to find a range. Okay, so for the range is we need to find the highest value and subtract the lowest value. So we have 83 and we have 0. So we have this. Okay, we need to round it off into an exact number, or shall I say a number that is not decimals, so that we could obtain the class intervals. Okay, so we have here, since we have 8 class, 1 to 8, then for our class intervals, okay, so we need to start for 0 and then add it by 11. So okay, we have 10, then but add by 11, 11, 11, so that we can obtain this number. Okay, for the class boundary is here we need to subtract. For the lower limit, we need to subtract 0 minus 0.5 is equals to negative 0.5. Okay, so we have here negative 0.5. So for the upper class is we need to add the upper limit to 0.5, so we could obtain this 10.5. Okay, so we have that. So that is just the sequence, so that we could obtain the rest of these following numbers. So for the class mark, okay, so we are about to add the class intervals, yes, and then divided by 2. Okay, so 10 plus 0 is divided by 2 is equals to 5. Okay, so that's how we get our class mark. Okay, so for our frequency is the number that is most appeared in this data presented. Okay, so for 0 to 10 is we have 17, then for 11 to 21 is we have 10, then the rest will follow. Okay, for our number 2, so for our number 2 example is we have the following data represent the weight distribution of a sample of 70 boys. Okay, so for the weight, we have here 15 to 44. So our number is 1, 5, 16, 28, 17, 3, into 17. So this is just a given. Okay, so what we need to do is to find out this. What is the class boundary of a third class interval? So the third class interval here is 25.4 and 29.2. Since we need to, if the lower limit, subtract it to 0.5, and for the upper limit is to add this for 0.5. Okay, so what is the class interval of mark of the fifth class interval? So we have 37. Okay, for the fifth is we need to add the fifth class interval and then divided by 2, the 34 and 39 divided by 2 is we have 37. Okay, 37. So how many frequencies do we have? So we have 70 frequencies, or the total number of moves appeared in the data. Okay, so for the number 3, the result of final exams in science for girls category who got the scores of 20 to 80 If one wishes for a frequency table with 6 class, what are the lower and upper limit of this frequency distribution, and give its mark and class width? So for our lower class is we have 20 to 70. Since we find the range of 10, for we subtract this 80 to 20 and then divided by 2, I divided by 6 so that we could obtain the 10. Okay, so we would start in 20 plus 10 is 30, 30 plus 10 is 40, and so on and so forth. Okay, so class mark, the same as what I have said a while ago, and here are the solutions. Okay, so for the ungrouped data, the ungrouped data is the data you first gathered from an experiment. Okay, Ali Leia has a 6 member of flowers in the salas and has 21 totals of frequency number. Okay, so we have here 1 to 6, and here's the frequency, and the XF is, we could find this by just simply multiplying the number of flowers and by the frequency. Okay, so 1 times 5 is equals to 5, then the rest will follow. Then, okay. So for the number 2, create an ungrouped frequency distribution table with the data from the questionnaire accomplished among the students of Immaculate Heart Academy, which answered the question of how many books they read annually. The answer are presented. So these are the number that is being presented here, and here the number of books. Okay, to 0 to 9. And the frequency, the number that most appeared, so we have this, and we have the total of 18 since they are all 18. Okay, so for the XF, okay, just same as what I have been said a while ago, so we need to multiply the number, or yes, the number of books they read, or the class intervals. So we have 0 and the rest will follow. So for the mean is, we have 76, since we have the total of this XF. 76 divided by 80 is we have 4.2. For the median is we have 9, is 18 plus 1. So since our frequency is 18, then our formula here is n plus 1 divided by 2. Okay, so that's our formula. Then for our mode is we have 9, that is most appeared. Okay, so the range is 9. Okay, so for cumulative frequency distribution table, it is calculated by simply adding each frequency from a frequency distribution table. So we have this example. Construct a cumulative frequency table for the grade of high school students in the Malinaw National High School. The grades are 90, 80, 70, 60. The number of students achieving those grades are 20, 21, 59, and 29. So we have here, okay, for the grades and the frequencies. And then, in order to get the cumulative frequency is, we need to copy this one, so that, yes, and then we need to add by this. Okay, 20 plus 21 is we have 41, and plus 29 is we have 70, and plus 52 is we have 122. So that's how we get our cumulative frequencies. Okay, so for the number 2, what is the cumulative frequency distribution of the following data presented in the table? So here, the number of chicken, 8 to 16, and the frequency 3, 2, and 5, and 6. So we have less than and greater than frequency distribution. So for the less than is, we need to first place the lowest number. Okay, so or shall I say preceding number. Okay, so we have 3 plus 2 is equals to 5, 10, and then 16. So for the greater cumulative frequency is we are about to place in decreasing form. So we have 16, 10, 5, and 3. So for the number 3, okay, there are 5 children in the park who has different complexion of skin. Construct a cumulative frequency. Okay, 2 black, white, 1 white, and 0 black and white. Okay, so we have this 1 to 5 children frequency. Okay, so for our less than cumulative frequency is, okay, we have this 2 plus 1, 3, 3, 3, 4, and the greater cumulative frequency. Okay. And for our relative frequency distribution table is shows the proportion of total number of observations associated with each number. Okay, so for 1, suppose that the frequency distribution is based on a sample of 50 supermarket. It turns out that 20 of the supermarket charge a price between 20 and 100 for a pound of coffee. Construct a relative frequency distribution. So the very first thing that we need to do is we need to find the range. Okay, 100 divided by 20 is equals to 5. So, okay, so we have this. Since we have the supermarket charge of 20, so we need to start here in 20. And then 20 plus 5, 25 plus 5 plus 5 plus 5, and the rest will follow. Okay, so we have 20 up to 103. So for the number of gas station is we have for the 20 to 25, 3 and 3, 4. This is the coordinate number of the number of gas stations, as you can see, as you can observe here. Okay, that's how they most appeared in the data. Okay, so we had a total of 20. For the class boundary is we have to, as what I have said, we need to subtract the lower limit by 0.5, and for the upper limit is plus, so we have this. Okay, same procedure as with that, and so on and so forth. For the class mark also is we need to add this 2 and then divide it by 2 so that we could obtain this 22.5. Okay, so this is 19.5 plus 22.5 divided by 2 is we have 22.5. Okay, here the class boundary. So for our class width is we need to subtract the upper boundary to the lower boundary. So we have this 25.5 minus 19.5 is equals to 6. Okay, so how do we get this relative frequency? Okay, we could get this relative frequency by simply dividing the number of gas stations or the frequency by its total number. So 3 divided by 20 is we have 0.15. Okay, so this is the answers of mine as I divided this number of gas station into its total number of frequencies. Okay, so for the second, my daily number of having fun outside home are 4, 4, 5, 3, 3, 3, and 2, 2, 2, 2, 2, and 1, 1, 1, and 0, 0. Okay, so we have the table 0 to 5. The frequency that is the most number appeared. So we have this. We have the total of 15. Okay, 2, 4, 6, 8, 10, 12, 14, 15. Okay, so for our relative frequency is we also need to divide this frequency to the total number. Okay, 2 divided by 3 is we have 0.13. The rest will follow. Okay, so in order for us to confidently say that our answer here is correct, if only we could obtain the 1 point, yes, 1.1 peso for our relative frequency, because that is his equivalent number. Yeah. So for the 3, we have the native eggs of chicken has reached the following numbers of 12, 5, 6, 8, 12, 4, 10, 20, 25, 30, 10 in a month. Okay, so for the eggs, is we need to arrange the number from lower to the higher. Okay, so we have the frequencies. Okay, so we have the total of 10, and then for relative frequency, as what I have said, divide this one by the total number of frequencies, so we could obtain 0.10, 0.10, 0.10, 0.10, and we have 1. Okay, so that's how that's end my video. Bye bye.
Good day, everyone. Today, we will talk about the graphs of frequency distribution. Our objectives: construct and analyze a frequency distribution. Make a pie chart, bar graph, and a line graph. In pie chart, it involves dividing circle into the proper proportions. For example, a college student daily routine. So, draw a pie chart using the data above. It is a table that illustrates a pie chart. 20% is for sleeping, 30% is for studying, eating is for 18%, bathing is for 12%, and others is for 20%. In a graph, there are two classifications of bar graph. It is a bar chart and a histogram. It is an example on how to construct a bar graph. So, first, construct a frequency distribution table for a pulse rate measurement obtained from a simple random sample of 40 males. Use 5 classes. Represents a frequency distribution table. Construct a bar chart for the frequency distribution constructed. So, we have here a frequency distribution table. So, we have the class interval and the frequency. So, our class interval is 56 to 64, 65 to 73, 74 to 82, 83 to 91, 92 to 100. So, before we come up with the frequency, we need to tally first the class interval according to our figure here. Example given. So, tally, we have frequency 56 to 64, we have frequency of 20, 65 to 73, we have the frequency of 8, 74 to 82, we have the frequency of 2, 83 to 91, we have the frequency of 8, and 92 to 100, we have the frequency of 1. So, our next step is construct a bar chart for the frequency distribution constructed. So, these are a bar chart example. We come up with this bar chart through this frequency distribution table. So, in a bar graph, we have two classifications, the bar chart and the histogram. So, the difference between the bar chart and the histogram, the bar chart, we have to use the class interval, while the histogram, we have to find the class boundaries to construct a histogram. To find the class boundaries, the class interval's lower limit and the upper limit. So, the lower limit of the class interval, we must subtract it to 0.5. And the upper limit, we must add to 0.5. To construct a bar chart, we must rely on our class interval frequency. So, we must draw a right angle. And this area is our frequency, this area is our class interval. So, our first class interval is 56 to 64. So, 56, 64, 65, 73, 74, 82, 83, 91, 92, 100. So, our first class interval has a frequency of 20. So, 56, ilocate nato siya to 20. And 64. So, it makes sense that it is our first class interval. And so on and so forth. So, in histogram, we will not use the class interval. Instead, we will use the class boundaries. So our class boundaries is 55.5, 65.5. So we must draw a right angle and locate the frequency and the class boundaries. So our first class boundary is 52.5 to 64.5. So 55.5 to 64.5. And the frequency is 20. So locate mo siya to 20. So our next objective is a line graph. So a line graph is a variation of the histogram. Bars are replaced by dots that are connected to form a line. So construct a frequency distribution polygon. So table 5, frequency distribution polygon. So our class interval. So to find to construct a polygon, we must first find our class mark. So to find a class mark, the class interval, for example, this first class interval 56 to 64. We must add this 56 plus 64 equals the total, divide it by 2, and the result is 60. So 65 plus 63 result is 69. 74.82 the result is 78. 83 to 91 the result is 87. 92 to 100 the result is 96. So a polygon is a form of line. So our class mark is 60, 69, 78, 87, and 96. So our frequency is 20, 8, 2, 8, and 1. So we must form a dot. So 60 has a frequency of 20, so and 20. And we must put a dot, so on and so forth, and we must connect it with a line, and that is an example of polygon. Construct a frequency distribution ogive. So, in frequency distribution ogive, we must use the class boundaries. In polygon, we use the class mark, but in ogive, we must use the class boundaries. So, our class boundaries is 55.5, 64.5, 73.5, 82.5, 92.5, and 100.5. Same with the frequency distribution. So, our ogive, we must arrange it to greater than to less than. So 20, 8, 8, 2, 1, and 0. So we must draw a right angle, class boundaries, and frequency. So we must form a dot, and construct it with a line. Using a graph, we can easily determine, read, and understood the message that was given. So that was all for the graphs of frequency distribution.
A pleasant day to everyone. It's another day to learn and explore. This is Mary Ann Magusara, a student of Bachelor of Science in Social Work. Well, today I will going to discuss the measure of central tendency for ungroup and group data. Measure of central tendency can be defined as the typical value of set data or observation where they tend to cluster. The mean is most likely the measure of central tendency that you are most familiar with, but there are others, such as the median and mode. There is also a way in organizing data in measuring central tendency. First is in group data. Those data that are not organized or may not be arranged according to their magnitudes. And the second is the group data that are organized data and arranged into class intervals presented in a frequency distribution form. The mean, median, and mode are all valid measures of central tendency. The mean or average is the most popular and well-known measure of central tendency. The median is the most middle value in a set of data. And the mode is the most frequent score in our data set. It is the number which appears most often. Mean for ungrouped data. Example, suppose a basketball team has 20 players and their heights in centimeter are as follows. So as you can see, there are scores in the screen, and then to find the mean of this data set, we have to add all the given scores and divide the result by 20, which is the total scores of the given set. So
The result is 192.15. So that's how we can get the mean for ungrouped data. For weighted mean, example, suppose that we are interested in computing the weighted mean of SW student in a certain university where is enrolled in 6 subjects having different unit loads as follows. As you can see the table, there is subjects, grades, number of units. So to find the weighted mean of this data set, we have to multiply the weighted mean, which is number of units, into the grades, which is x rather, which is the grades, and then add all the results, and then divide it by the total weight, which is 18 units, and the result is 2.29. So that's how we can get the weighted mean of the data set. Median for ungrouped data. For add sample, in a mathematics class, 23 learners completed a test out of 25 marks. Here is a list of their results. So, to calculate the median of this data, first put the data in order from lowest to highest and then get the total number of scores. So, for median, add sample rather, n plus 1 divided by 2. So 23, which is the total number of score, plus 1 divided by 2 equals 12. So there are 23 numbers. So the middle number is the 12 out of 23 numbers. So 16 is the median, the number in the middle of the data set. So you can see 16 is our median for add sample. For median even sample, what if another learner wrote the test and her result was 7? We can add this to the ordered data set. So again, to put this data in order, so from lowest to highest, and then get the total number of score, which is 24, and then for median or for even sample, the median lies halfway between the middle of two values, so the 12 and the 13. So for 12 value, which is 14, and the 13th value is the 16. So we can add these two values and then divide it by 2 rather, so that we can get the median for even sample. So the result is 15. Code for ungrouped data. In mathematics class, 23 learners completed a test out of 25 marks. Here is a list of their result. So 13 is our mode in this data set, since it is the number that appears most often. So the second, find the mode of the following data. So we have two modes, so that is what we call bimodal, since it has two modes. So the first mode is 7, and then the second mode is 11, since 7 occurs 4 times rather, and then the 11 occurs also 4 times. In median mode for group data, the following tables give the frequency distribution of the number of orders received each day during the past 50 days at the office of a mail order company. So calculate the mean median mode for group data. So to calculate the mean of group data, first step to do is to determine the midpoint of each class interval. So to determine, we have to add the lower boundaries and the upper boundaries and then divide it by 2. So for example, 10 plus 12 divided by 2 equals 11. So we come up the midpoint of the class interval of 10 to 12. So after that, these midpoints must then be multiplied by the frequency of the corresponding classes. So frequency multiply to the corresponding classes. So 18 times 11 equals 108. So the sum of the products divided by the total number of values will be the value of the mean. So to solve the mean, you have the formula equals mean equals fx over n. So the fx is the total or the sum of the products, and then divide it by n, which is the total frequency. So the result is 16.94. Median group data. The first step that we do is to determine the median class. Divide n by 2's and then construct less than cumulative frequency. So to construct less than cumulative frequency, we have to add each frequency from the frequency distribution table to the sum of its predecessors. The last value will always be equal to the total for all observations, since all frequency will already have been added to the previous total. So, for example, 16 plus 24 equals 40. So 40 plus 20 equals 60. So 60 plus 22 equals 82, and 82 plus 18 equals 100. So this is our less than cumulative frequency. And then locate the n over 2 in the cumulative frequency to determine the median class. So to locate, so our n is 100. So we divide it by 2 so that we can locate the median class. So 100 rather divided by 2 equals 50, since there is no 50 in our cumulative frequency. So 60 is our median class. So after that, get the lower boundary of the median class so that we can solve for median. So the lower boundary is 16. So 16 minus 0.5 equals 15.5. So our lower boundaries is 15.5. Then from the computed n over 2, subtract the cumulative frequency before the median, which is 40. So our median is 50 minus cumulative frequency before the median is 40. So there. So 15.5 plus 50 minus 40 over 17, which is our frequency of the median class. So as you can see, our frequency median class is 17. So our class interval, class size rather, is 3. So if we count 10, 11, 12, so 3 our class size. So the answer is 17.26. So that's how we can get the median for group data. The mode of group data. So there is the class interval and then the frequency. So determine the model class. So the model class is the highest frequency in the distribution table. So as you can see, 24 is our model class since it is the highest frequency in the distribution. And then get the lower limit of the model class. So the lower limit of our model class is 18.5, since our lower boundaries is 19, and then 19 minus 0.5 equals 18.5. And then determine the difference of the highest frequency and the frequency just below it, and the difference of the highest frequency and the frequency just above it. So our frequency that just below it is 16, and then the above it is 20. So as you can see, this is the formula for calculating the mode. So our lower boundaries is 18.5 plus our frequency just below it is 24 minus 16, and then our frequency just above it is 24 minus 20. Our class size is 3, so the answer is 20.5. So true mode is x is equals to 3 median minus 2 mean. So we just simply distribute our median and the mean, which is our median is 17.26, our mean is 16.94. So get the difference and then you can get the true mode. So for crude mode, we have to add the lower limit and the upper limit and then divided it by 2, so we can get the crude mode. So that's all for measure of central tendency for group and group data.
Hey guys, welcome to my vlog. It's me again, Riza Meme Paranum. And for today's video, we're going to talk about the measures of central tendency, which is the mean, median, mode of group and ungroup data. But before that, we're going to define what is mean, median, and mode. So mean is the number that is representative of the data. And the median, it has two kinds, the odd and even median. So odd median is the middle number when the data are arranged in order, and even when the mean of the two middle numbers. And for the mode, it is the number that occurs most often in a set of data. So we're going to solve the mean of the group data, which has the formula of x bar is equal to Fm over n. So for the table, it has a total frequency number of 4,400 and the total number of cases is 50. So 4,400 divide 50, it has a result of 88. So that is the mean. So for the median, it has a formula of x tilde is equal to x lower boundary of the median class plus n over 2 minus f over fm times I. In the table of the senior citizens age, the median class is in the third column, and it has the lower boundary of 84.5 plus 50, which is the number of cases, over 2 minus 12 over 30 plus 5. So it has a result of 86.668. And for the mode, it has a formula of current x is equal to lower boundary of the model class plus the difference of the highest frequency just below it over the difference of the highest frequency just below it plus the difference of the highest frequency just above it times class size. So it has a lower boundary of 79.5 plus 5 minus 6 over 5 minus 6 plus 5 minus 18. So it has a result of 0.79. 028 times 6 and plus 79.5, so it has a result of 79.928. So now we will go to the mean of ungrouped data. So it is the data of 85, 90, 76, 108, 85, 80, 10, 85, 70, and 95 over 10, which is the total number of observable data. So it has a total of 880 over 10. So the result is 88. So that is the mean. And next, we're going to tackle the median for even samples. So what we are going to do is we're going to arrange the data listed from less to greatest. So the median is in the 5th and 6th observable data. So we're going to add up to 85 plus 85 over 2. So it has a result of 85. So that is the median for even samples. So median for odd samples is we're going to use the data that we're using earlier. So we add 116 last observable data for the data so that we can make it an add. So the median is in the 6th observable data and it is 85. So the mode for ungrouped data is we are going to find the numbers that is repeatedly observed in the data. So 85, it is happens in 3 times. So that is the mode. So guys, that is the end of my vlog. I hope you learned something and don't forget to like, share, and subscribe. Paalam!
Hello guys, so for today's video, I will discuss to you the measures of location or position. So in measuring the location or position, we have the quantiles. So quantiles is defined as an extension of the median concept where items in the distributions are divided into equal parts. So we have 3 types of quantiles. So the first is the quartiles, deciles, and percentiles. So when we say quartiles, it is a statistical term that divides the distribution into 4 equal parts. And when we say deciles, it is a statistical term that divides the distribution into 10 equal parts. And when we say percentiles, it is a statistical term that divides the distribution into 100 equal parts. So I have here a table. So this table is the weight of grade 11 students in first section. So we have the class interval, the frequency, and the cumulative frequency. So what we need to do is we need to determine the Q3, D5, and P7. Okay, let's start. So first, we need to solve for the Q3. So we have Q3 is equals to LB. So this LB serves as the lower boundary. Then Q3 plus divided by 4 minus greater than frequency over FQ3. So next, we need to solve for the Q3 class. So we have the 3n divided by 4 is equals to 3 times 30 divided by 4. So we have 22.5. So this is our Q3 class. So after that, we need to go in our table and we need to spot the Q3 class. So we have 22.5. So we don't have 22.5 in our table, but in measuring the location or position, if we don't have that number, so we have go to the another higher number. So we have 24. So our 24 is our Q3 class. So let's proceed. So next we have Q3 is equals to 49.5. So why 49.5? Because we have here in our formula is the lower boundary of the Q3. So our lower boundary here in the table is 49.5 because 50 minus 0.5 is equals to 49.5. So 49.5 is our lower boundary in Q3 class interval. Then plus the 3n divided by 4 minus 19 over 5. So why it came up to 19? So it is 19 because 24 minus 5 is equals to 19. So this is what we put here. So then divided by 5. So why 5? Because the frequency here is 5. So the frequency of Q3 class interval is 5. So we put 5 here. So then we need to multiply it by 5. So why 5? It's because our I here is served as our width. So in computing the width, we must subtract these two. So the first lower boundary and the second lower boundary. So the answer is 5. So our I here is, or class width is 5. So the Q3 is equals to 53. So we must subtract here 22.5 minus 19, then divided by 5, and then multiply to 5. And after that, we must add 49.5 to the answer of this. So the Q3 is equals to 53. So let's proceed to finding the D5. So these are 5. So yeah, D5 is equals to LB Q5 plus 5 and divided by 10 minus, then divided by F Q5, and then the width. So next, we must first find the D5 class so that we can put it here in our table. So we have 5n divided by 10. So we have 5 times 30. So why 30? Because our overall total in our frequency table is equals to 30. So here we have 30, then divided by 10 is equals to 15. So our D5, so this is our D5 class. So let's go here in our table. So the D5 class is 15, but we can see here number 15. So what we need to do is find the next up higher number than 15. So we have 19. So 19 is our D5 class. Okay, let's go on. So next we have D5 is equals to 54.5 plus 5 and divided by 10 minus 11 divided by 8 times 5. So our D5 is equals to 57. So it is same process just like with the Q3. So next we proceed to finding the percentile. So we have P7 is equals to LG Q7 plus 7n divided by 100 minus greater than cumulative frequency, then divided by frequency of Q7, and then D cosine. So next we have 7n divided by 100 is equals to 7 times 30 divided by 100 is equals to 2.1. So our P7 plus is 2.1. So let's go again to our table. So our P7 is 2.1, but we can see here 2.1. So just like other procedures, we must go in 6. So 6 is our P7 class. Then let's continue. P7 is equals to 64.5 plus 7n divided by 100 minus 2 divided by 4 multiplied by 5. So R is 7 is equals to 64.63. So this is how we compute measures of location or position. So that's all. Thank you.
Hi everyone, my name is Gorgonio aka My Ragsugod.
Oh my god!
So today let's talk about the measures of dispersion. Measures of dispersions, the examples of ungroup in group data. So let's start.
Measures of dispersion. So what is measures of dispersion? Are descriptive statistics that describe how similar a set of scores are to each other. So types of measures of dispersions are range, variance, or standard deviations, and coefficient of variation. So first, let's define what is range. So range is the difference between the largest scores and the set of data and the smallest scores and the set of data. So example. So our given examples are 4, 8, 6, 2, 9, 1, 3, 6, 9. So to get the range, we will subtract the highest and the lowest set of data. So our highest is 9 and our lowest is 1. So we will subtract it. So 9 minus 1 is equal to 8. So our range is 8. Next is variance. Variance is defined as the average of the square deviations. So, these are the formula for the sample. S squared is equal to summation of xi minus x squared over n minus 1. For the population is sigma squared is equal to summation of xi minus population mean squared over n. Next is standard deviation. Standard deviation is the square root of variance. So, these are the formula. For example, S is equal to square root of S squared. And for the population is sigma squared is equal to square root of sigma squared. Next is coefficient of variation. So it tells if a standard deviation is large or small by comparing the standard deviation to the mean. So the formula of coefficient of variation is CV is equal to S over X bar times 100%. So examples of measures of dispersions of the group data. So our examples, so they have the grade, the frequency, the x, the fx, x minus x bar squared, and f multiplied by x minus x bar squared. So our grade is 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 100. So our frequency is 26886. So the overall is 30. So next is to get the x. So we need to add the grade, the 59 and the 50, and we'll divide it into 2. So 59 plus 50 divided by 2, so 54.5. And 69 plus 60 divided by 2 is 94.5. 79 plus 70 divided by 2 is 74.5. 89 plus 80 divided by into 2 is 84.5. And 100 plus 90 divided by into 2 is equal to 95. So next is to get the fx. So we need to multiply the frequency and the x. So 2 times 54.5 is equal to 109. 6 times 94.5 is equal to 567. 8 times 74.5 is 596. 8 times 84.5, 676, and 6 times 95 is equal to 570. So the overall total of fx is 2518. So next is to get the x minus x bar. But before that, we need to solve the x bar first. So this is the formula for the x bar. So summation of fx over n. So our fx total is 2518, and our n is the total frequency, which is 30. So 2518 divided by 30, so our x bar is 83.93. So now we will solve the x minus x bar. So first things to do is subtract the x from the result of our x bar. So our x is 54.5 minus 83.93 is equal to negative 29.43. And next is 94.5 minus 83.93 is equal to 10.57. And next is 54.5 minus 83.93 is equal to negative 9.43. And the next is 84.5 minus 83.93 is equal to 0.57. And the last is 95 minus 83.93 is equal to 11.07. Next is to get the x minus x bar squared. So the squared of negative 29.43 is 866.12, and the squared of 10.57 is 111.72, and the squared of negative 9.43 is 88.92, and the squared of 0.57 is equal to 0.324, and the squared of 11.07 is 122.54. So the last column is the f multiplied by x minus x bar squared. So we need to multiply the frequency and the x minus x bar squared. So 2 times 866.12 is equal to 1732.24, and 6 times 111 times 72 is 6706.32, and 8 times 88.92 is equal to 447.36, and 8 times 0.324 is equal to 2.592, and the last is 6 times 122.4 is equal to 735.2. So the overall total of the x times x minus x bar squared is equal to 9,623.752. So this example will solve the range, the sample variance, the sample standard deviation, the population variance, the population standard deviation. So to solve the range, we will subtract the highest and the lowest set of data. So our highest is 100 and our lowest is 50. So 100 minus 50 is equal 50. So our range is 50. So to solve the sample variance, so these are the formula. So s squared is equal to summation x times x minus x bar squared over n minus 1. So our s squared is equal to, so our total of the f x minus x bar squared is 9,623.752, and we'll divide it into our n, which is 30 minus 1. So 9623.752 divided by 29, so our s squared is 331.853. So to solve the sample standard deviation, so the formula is s is equal to the square root of s squared. So the result of our sample variance is 331.853. So the square root of 331.853 is 18.216. So this is the sample standard deviations. And to get the population variance, so the formula is sigma squared is equal to summation of x multiplied by x minus x bar squared over n. So our result of the f minus x bar squared is 9,623.752 divided by our n, which is 30, is equal to 320.791. So this is the population variance. And to solve the population standard deviation, so the formula is sigma is equal to square root of sigma squared. So the result of our population variance is 320.791. So the square root of 320.791 is 17.909. So these are the examples of the measures of dispersions of the group data. So another examples of measures of dispersions of the ungrouped data. So here are the samples. So the X is 10, 15, 18, 25, 28, and 30. So to get the X minus X bar, so we need to add this all X and we'll divide into 6. So 10 plus 15 plus 18 plus 25 plus 26 plus 30 is 126. And we'll divide it into 1, 2, 3, 4, 5, 6 is equal to 21. So to get the X minus X bar squared, so we need to subtract the X and the result of the X bar. So 10 minus 21 is equal to negative 11, and 15 minus 21 is negative 6, and the 18 minus 21 is negative 3, and the 25 minus 21 is 4, and the 28 minus 21 is 7, and 30 minus 21 is 9. So next is to get the X minus X bar squared. So we need to, the squared of negative 11 is 121, and the squared of negative 6 is 36, and the negative 3 squared is 9, and the squared of 4 is 16, and the squared of 7 is 49, and the squared of 9 is 81. So the overall total of this X minus X bar squared is 312. So in this example, we'll solve the range, the sample variance, the sample standard deviations, the population variance, and the population standard deviations. So range. So we will subtract the highest and the lowest. So our highest is 30 and the lowest is 10. So 30 minus 10 is equal to 20. So our range is 20. So to solve the sample variance, so these are the formula. S squared is equal to summation of X minus X bar squared over N minus 1. So our X minus X bar squared is 312, and our N is 6, and we'll be minus it into 1. So 312 divided by 5, so our S squared, or the sample variance, is 62.4. So for the sample standard deviation, so the formula is S is equal to the square root of S squared. So our sample variance is 62.4. So the square root of 62.4 is 7.899. So this is the sample standard deviations. And for the population variance, so the formula is sigma squared is equal to summation of X minus X bar squared over N. So our X minus X bar squared is 312, and our N is 6. So 312 divided by 6 is 52. So the population variance is 52. So for the population standard deviation, so the formula is sigma is equal to the square root of sigma squared. So our population variance is 52, and the square root of 52 is 7.211. So this is the population standard deviation. Next is to solve the coefficient variation. So this is the formula. The CV is equal to S over X bar multiplied by 100%. So our S, or the sample standard deviation, is 7.899, and our x bar is 21, so we'll divide it into 21. So 7.899 divided by 21, and we will multiply it into 100%, so it's equal to 37.614. So these are the coefficient variation. So these are the examples of the measures of dispersions of the ungrouped data. So that would be all. I hope you learned something. Thank you.
My assigned topic for today is all about the measures of dispersion. Number 1, range. Range is the difference between the greatest data value of the least data value. Example letter A, we have number 1, 2, 5, 7, 8, 19, and 22. And since naka-arrange na ni siya, so ang atong buhaton is we look for the greatest data value and the least data value. And for here, our greatest data value is 20, 22. And our least data value is 1. 22 minus 1 is equal to 21. For here, letter B, we have negative 8, negative 5, negative 12, negative 1, positive 4, positive 7, and positive 11. This time, kailangan na nating i-arrange ang mga numerong ito para mas madali nating mahanap yung greatest value and the least data value. Okay. I-arrange muna natin. Negative 12, negative 8, negative 5, negative 1, positive 4, positive 7, and positive 11. Okay. Since our greatest value is positive 11, of course, even though we have 12, but then naka-negative man siya, so lowest lang gihapon siya, even though 12 siya. So our greatest data value is 11. And our least data value is negative 12. Since negative, and then ma-distribute na ni siya into positive. 11, 12 is equal to 23. That is our range for letter B, 23. Here we have group data for the range. How to get the range in group data. Kasi kanina, nakuha natin yung range, and group yon. At ito, group data na naman tayo. Okay. Given here, we have age, we have 10 to 12, 13 to 15, 16 to 18, 19 to 21, 22 to 24. And the frequency given is 5, 8, 5, 10, 2. Okay. That is for the group data of the range. Okay. We need to get the class boundaries. Okay, for the 10 to 12, the class boundaries there is 9.5 to 12.5. Next, 12.5 to 15 15.5. Then 15.5 to 18.5. Then 18.5 to 21.5. Then 21.5 to 24.5. Okay. We have already get the class boundaries. Next, the formula of the range is R is equal to highest upper class boundaries minus least lower class boundaries. Okay. Our highest upper class boundaries is 24.5 minus the least lower class boundaries is 9.5. 24.5 minus 9.5 is equal to 15. And this is our range for the group data. Next, we're going to proceed to number 2, which is standard deviation. Standard deviation is a set of numerical data that makes us of the amount by which individual data value diverges from the mean. Okay, there are two ways para makasolve ka sa standard deviation. First is the standard deviation for population and standard deviation for the sample. Okay, the formula for population is sigma is equal to square root of summation for x minus mu to the power of 2 is equal to n, or the number of numerical data. For the standard deviation of sample, here, sample is equal to, or S is equal to square root of summation for x minus x bar to the power of 2 is equal over n minus 1. Here, this symbol, this is a standard deviation for population, and S, standard deviation for the sample, and X is the numerical data. This symbol, mean of the population, and X bar is sample mean, and the N is the number of numerical data. Let's proceed first to the number 3, which is the variance data. Let's proceed first to the number 3, which is the variance. Variance is square of the standard deviation of the data. Since variance is square of the standard deviation, siya yung square root. The square root of the standard deviation of the data. That's why ang yung formula for the population is sigma to the power of 2 is equal to summation for x minus mu to the power of 2 over n. Here in the sample, s to the power of 2 is equal to summation for the x and x bar to the power of 2 over n to the power of 1. Okay, for now, we're going to find out the range, standard deviation, and variance of the given sample data in ungroup siya. Okay. Since ang range, we need to find out the highest data value and the lowest data value. Okay. Since naka-arrange na siya, so we need to find out the highest and the lowest. Okay. 15 minus 2 is equal to 13. And that is our range. Letter B, we need to find out the standard deviation. And we can see here natay box. No. Table rather. We have a table here. And nakasulat X, which is the given numbers. 2, 5, 8, 10, 15. Kani siya nga side, X minus X bar. And here, X minus X bar to the power of 2. Okay. From the given data, which is 2, 5, 8, 10, 15. So, muna siya atong numerical data. Numerical data or the given data nga ato siyang i-solve. So, from that, kailangan nato na siya i-add tanan para sa tong mean. Okay. 2 plus 5 plus 8 plus 10 plus 15 over. So, our numerical data, we have 5. So, since 5, so, mao na siya ang atong i-divide. 5. And the result is 8. That 8, mao na siya atong ibutang diri. So, X, since X, madirito siya nagkuha, X minus X bar. Ang atong mean is 8. That's why 2 minus 8 is equal to negative 6. Then, 5 minus 8 is equal to negative 3. 8 minus 8 is equal to 0. And 10 minus 8 is equal to 2. 15 minus 8 is equal to 7. We're done. Next column is X minus X bar to the power of 2. So, madali lang to kasi kung anong result dito sa side, lagyan na natin ng to the power of 2. Okay. Negative 6 to the power of 2 is equal to, so ma-distribute na siya. So, magiging positive na. So, is equal to 36. Negative 3 to the power of 2 is equal to 9. Negative 0 to the power of 2, still 0. Then, positive 2 to the power of 2 is equal to 4. And positive 7 to the power of 2 is equal to 49. Okay, we're done.